focusing on our lake monitoring program. There's other things that I do there as well. It's providing technical assistance with lake monitoring and lake assessments, things working on TACs for technical assistant committees for working with various watersheds and also state agencies as well. But I'm going to pretty much focus just on the lake monitoring program. It's a program that's been around for quite a while. So thanks for having me, and I'll get into it here. Overall, let me talk first of all about the purpose of the program, and the program is to provide water quality data and information to the council and our partners, and that to help effectively manage the lakes of the region. And so we've been doing this since 1980, and part of this is determine lake water quality conditions and the status of water quality. Basically, we're focusing on water eutrophication status, trophic status of lakes. It's one of the bigger problems in the Twin Cities area. That's been one of our main focuses since the beginning, but we've since expanded that to other issues such as chloride and issues related to that as well. And also, one of the hopes of this is that we developed quite a long database since going back to 1980, almost 40 years of data, and that can be useful and helpful in determining water quality trends. Whether water quality in lakes have been getting better or worsening, or maybe even staying the same. And then also we're assisting local governments to assess the effectiveness of its lake management efforts. So this data can be used at a local level for cities or counties or watersheds to evaluate if the BMPs are putting into the watershed are having an effect on water quality in a lake, or whether they're putting in other in-lake practices that might improve water quality. So this data is helpful in seeing if their efforts are having an impact. And so then why does the council monitor lakes anyways? The council is involved with a lot of things. It's basically a regional planning organization. It's a regional planning government entity, and it is jurisdictions over the 7-county metro area. And part of the charge of the council is to develop a long-term 10, 20-year plan for development planning of the area. And part of this involves water resources policy planning. And so every 10 years, the council has to update their plan. And in that has several policies and how the council is involved with helping guide and improve the water resources of the region. And part of that, we have a priority lake list within that policy plan, which the council has developed some criteria for prioritizing certain lakes. And so the last one we had was a 2040 water resources policy plan, which is updated about 5 years ago or so. And now we're in the process of getting ready to plan for the next one, for the 2050 water resources policy plan. And so a part of that, we're going to be updating the priority lake list as well and looking at other policies to see how they fit in with the latest issues that are pressing for the region. And so it's part of that. We have strategies for assessing and protecting the regional water resources of the region. So it not just includes lakes, but it also includes streams and rivers as well. The policy plan also includes drinking water. We have a section in the council that deals with regional drinking water, and also rivers. I already mentioned that, rivers, but then wastewater treatment as well. The council is the region's wastewater collection and treatment system, and that involves several wastewater treatment plants through the region. So part of that water resources policy plan includes wastewater as well. So the lake monitoring program consists of two components. One is we have a program where Metropolitan Council staff do the monitoring, and we tend to focus on the priority lakes. There's about 130 in their area. I'll show you a map here's coming up showing those priority lakes. So we have staff that do that, and we do fairly intensive monitoring for a given year, and collect surface water samples at depth samples, and also doing water, lake depth profiles as well. Then the other component is our Citizens Assisted Monitoring Program, which we call the CAMP for short. And what that does, it expands our regional coverage of monitoring lakes. So it goes beyond our priority lakes in their area. And so that addresses local priorities that local units of government would be concerned about. And that engages citizen scientists, volunteers, who then we hope, and many do, advocate for water quality, good water quality for the region. And those, the CAMP program itself is divided up into what we call like the volunteers, but we're truly a true volunteer, someone who gives their time without pay. But then we also incorporate staff from some sponsoring organizations. We call that Pro Camp. And a lot of the reason behind that is that, volunteers are actually kind of sometimes hard to find, and the need for lake monitoring and getting data for these lakes to meet various issues, whether it's determining the status of water quality or responding to TMDL studies and implementation of TMDLs, things of that nature. Sometimes staff have to step in and do that monitoring. So we have a role in the CAMP program overall for this Pro Camp. So those are the two components of the program. I just want to show you a little history of the program, just to give you an idea of how it's expanded over time. Now, the lake program started in 1980. Dick Osgood started the program, and at that time it was just MCES staff, or not MCES, but just council staff that were doing the monitoring. And then about 1988, Dick Osgood created the lake grading system, which is a A through F grading system for the water quality of the region's lakes. And I'll talk about that in a little more detail later. And then in 1993, the Citizens Assisted Monitoring Program started up. So that's when our volunteer program kicked in. Then you can tell then after the camp begins, the number of lakes enrolled in the program just increased steadily, basically from under 50 in 93 to up to 200 or so, just under 200 by the middle 2000s, which is a pretty substantial increase. And we did not have any increase in staff to deal with that. So it's been quite a workload. Again, I'll talk about the priority lakes list in a few minutes here, but that list was first created then in 2003 or so. And part of that was to respond to this increasing trend of the quantity of lakes in the program. And then 2015, the priority lake list was updated as part of our 2040 water resource policy plan. And so then right now, see, this last year that we did it for a full season was 2019, and we had just about 165 lakes or so. And so on average, we're doing anywhere from 160 to 180 lakes over the past few years. Now the whole scope of the program, there's 950 lake basins in the 7-county Twin Cities metropolitan area, and that is based on the DNR's lake inventory that they did back in 1968. So these are lake basins that are greater than 10 acres in area. We have not hit all those, but just give you an idea of what we did in 2019. Hold on a minute, I gotta. All right, how about that? I have a child back there doing some singing. Yeah, so we did 177 lake sites on 162 lakes in the metro area. That was a combination of our staff program and our camp. And so some lakes have multiple sites on them, and that's why we have more lake sites than the lakes. And since 1980, we've monitored or about 442 lake sites and 400 lakes. So as you see, we haven't even hit half of the lake basins in the 7-county area. There's lots of lakes out there. And as part of the program too, we like to collaborate with others in the region that are doing lake monitoring. We're not the only one, and there are some cities and a few watershed districts and watershed management organizations that are doing monitoring. The PCA does monitoring as well, and occasionally the DNR in the area. So we like to stay in contact and talk with those water resources staff and those other units of government to coordinate our efforts. And part of that is to avoid duplication of monitoring efforts in order to save limited government resources, time and money. So get more done with spreading the work around, basically. And then we tend to focus this, at least coordination with local units of governments with our priority lakes. So if they're monitoring other lakes that are not necessarily part of the priority lakes, then we're not too involved with that. But we just want to make sure the council's priority lakes are monitored, getting the right amount of data for those lakes. And then also we can then just not coordinate but support the local units of government for lakes that they are or they deem important to them, and we do that through our camp program. So our camp is not just limited to the priority lakes. If one particular community has a lake that's a priority for them and they want to get some data on it and get some citizen involvement, they basically send in a request to us to roll that in the camp, and then we can help them out with that. Also, we collaborate with state agencies with monitoring assistance. For example, we've worked with PCA and gathering more data off of Lake Byllesby down in southern Dakota County, and also Chubb Lake, which is in Dakota County. That's a tributary lake to the Cannon River. Chubb Lake is the headwaters of Chubb Creek, which then flows into the Cannon River, which then Lake Byllesby is an impoundment of the Cannon River. Another thing I didn't done here is the chloride monitoring that Brooke mentioned before, part of the Metro Chloride project. Tried to establish chloride conditions in the metro areas, lakes, and we were part of that to help information on lakes that other watersheds and cities aren't able to get to. What's interesting with the Lake Byllesby project is the Lake Byllesby has a TMDL on it, and also part of the Cannon River. And with the PCA that they're with the change over to looking at watershed monitoring on a 10-year cycle, the project manager Justin Watkins is looking for help and seeing if we can get some more detailed, more refined timing on monitoring. So we went in there and we monitored that lake yearly for 3 years, and then before that it was yearly for 2 years. So I'm going to have to show some data on that, based on trends that we're seeing with that collaboration. And also there's some coordination between the camp and the PCA's Citizen Lake Monitoring Program, or the CLAMP. And then in that case, sometimes the CLAMP gets some requests for monitoring, and that gets passed on to me to see if more in-depth monitoring is needed, and that's always a good thing to keep in touch and work across both programs to help each other out. So let me then. So that's kind of the kind of a rough outline of how the program's structured and why we're doing these things. But let me just talk to you too about the priority lakes. And again, the purpose of the priority lakes list is to focus limited resources to better manage the region's lakes. We can't hit them all, and so we focused on these certain lakes that have certain criteria. And this map here shows the dark blue are the priority lakes, and the green are actually our regional park system. But before I was mentioning Chubb Lake, that Chubb Lake is down here, southern Dakota County. I assume you can see my mouse. And then also Lake Byllesby is down here, the border of Dakota County. We'll get a little more of that data later. But what defines a priority lake for us is one category is called a high regional recreational value. And this is defined as a lake that has a public boat access, an adjacent park, and it needs to have a surface area greater or equal to 100 acres. So if it fits into those, if it has those three criteria, then we prioritize that lake and call it a regional recreational value lake. Another type is a water supply lake. There are a few in the metro. It needs to be defined in Minnesota state rules as a drinking water beneficial use, and then also identifies a drinking water source in the LG's water management plan. And this is particularly important with respect to the St. Paul Regional Water Utility. Some of those lakes are up here in this region. Let's see, there's Charlie Lake and Lake Vadnais, Pleasant Lake. These are considered water supply lakes. Water is drawn from the Mississippi River over in this area. I believe it's Fridley, and then it's pumped underground to a pipe to Charlie Lake, and then it flows through these various lake systems down into Vadnais, where the intake for the water treatment plant is located. And then there's some reserve lakes, water reserve lakes up here, particularly Centerville Lake. So in case there's a need for a backup water supply, this lake up here is part of the drinking water supply backup. So there are water supply lakes in the metro, and those are prioritized. Then the other category is a good water quality lake. Essentially, this is an A-grade lake. It's got clear water, low concentrations of phosphorus and chlorophyll. So we want to keep an eye on those, and make sure keep an eye on them for any trends towards worsening conditions, and try to maintain our good water quality. And then another category that was added in our last priority lakes, or our water resources policy plan, we added a special significance for wildlife. The three other categories I mentioned before, those are the original prioritization categories. It was first developed in the early 2000s. But we added a special significance for wildlife as a means to help to incorporate shallow lakes into the priority lakes. They seem to be underrepresented, even though those lakes do provide important services, ecosystem services, and other beneficial uses to people in the region. And so what we came up with some criteria. One of those is these lakes are designated. Some lakes are designated, excuse me, already, and the DNR has some designations for migratory waterfowl feeding and resting areas, also designated wildlife lakes. And so there's a few in the metro that have these designations, and so use that as a way to having significance for wildlife. And one of the reasons why we pick significance for wildlife is not only to incorporate shallow lakes, but they, so many shallow lakes have, other recreational opportunities or value beyond like a large lake. Some of these smaller lakes provide more, I don't know, solitude and a more peaceful type of experience. So it's good for canoeists and kayakers and others that don't want to be around water skiers and large boats and things like that. So they do provide other uses, but they're also good for providing habitat for wildlife, particularly waterfowl. And then also another category is if they had documented stands of wild rice. That's an important food crop, and it also has some cultural significance, particularly here in Minnesota. And so Minnesota DNR had a wild rice survey that they've done, and we use that as a basis for determining, what lakes in this area have wild rice or had wild rice at one point. And we could use that as a way to document or to prioritize important lakes in the region. So that's our priority lake system. So going a little more detail on our staff monitoring program, I mentioned before, our main goal is we focus on trophic state because that's a big issue in the Twin Cities area since it affects recreation so highly and the use of the lakes. We also expanded chloride condition monitoring after the Metro Fluoride Monitoring Project. We added chloride to our program as well. And so we do surface monitoring and at depth monitoring as well. So if the lake's deep enough, we'll collect water just above the bottom. And we look at various nutrients such as total phosphorus, orthophosphorus. And the past 2 or 3 years, we we added nitrate, nitrite, and ammonia to our suite of parameters, considering their importance in harmful algal blooms and cyanobacteria blooms. And so we added those. And then total Keldol nitrogen we've always done. And so we collect those at the surface and at depth. And then we'll do chlorophyll analysis for the surface. And then we also add in ions, chloride, which I mentioned, sulfate, magnesium, calcium. And then we also look at these others, iron, alkaline hardness. We just added dissolved organic carbon too to try to get an idea on that biogeochemical cycle, so to speak, going beyond, just the phosphorus and nitrogen. And then we also do field measurements and observation on each visit, water clarity using a Secchi disc and weather conditions, lake conditions, and also depth profiles for a standard suite off of our SON that we use. So temperature and dissolved oxygen, pH, a lot of standard stuff. Now, our citizens assisted monitoring program, since we use volunteers for this, it's not nearly as in depth, but we're very lucky to have a lot of volunteers. We had 123 citizen volunteers in 2019, and as part of that, we added, there's addition to that is monitoring staff from 5 local partners. So I mentioned we had that pro camp, and one of our largest ones with the Washington Conservation District, but we also have staff from Lakeville and Chanhassen and others that will fill in for volunteers that they cannot find. And we have 27 camp sponsors, and the sponsors are the local units of government that sponsor a volunteer. And so we have kind of a 3-way relationship or with the camp. There's the Metropolitan Council, there's the volunteer, and then there's their sponsor. And these sponsors are, as I said, LGUs or cities, watershed management organizations, counties, conservation districts, and also an interstate basin planning team, which is a kind of a loose group of various state agencies between Minnesota and Wisconsin, and they're involved with kind of management and planning and monitoring for Lake St. Croix. And so that's what that interstate basin planning team is. And so we have several volunteers that monitor 7 sites on Lake St. Croix. So that's been a successful collaboration. So the volunteers focus on the surface monitoring only, and they're looking at trophic state parameters, phosphorus, nitrogen, chlorophyll, and also water clarity, temperature, general lake weather conditions. And so they generally go out once every 2 weeks, sometimes once a month, and collect water samples for analysis of these parameters and also take their measurements. And then we get those samples, analyze them at our lab, and get all that information into our database. So I touched briefly on the relationship of the people in the camp, but just want to get you an idea a little more of what they're involved with. So the volunteers, they kind of sit at the top of this triangle, and they're supported underneath by the sponsor and the council. But the volunteer then, they monitor the lake on schedule. They're responsible for storing the samples. They need to store them frozen. That's how we preserve them between pickups. And then they have to record field data, and they also have to attend a training. The training is very important. We need to show them the methods and the proper procedures. We used to do this in person, and that got quite busy trying to go over the metro and train these volunteers because of timing and coordination. Not everyone can make it at a particular time, but we need to train them. It's very important to maintain our quality control. So we this year we just implemented for the first time an online training course that involves watching videos and taking embedded quizzes, and they have to take a final assessment at the end and they have to pass it, that kind of thing. And so it's a pretty rigorous training, and it's been quite successful. We have pretty good luck with it, and we're happy about that. Saves a lot of time. Then the sponsors, they pay fees for the lab costs and monitoring equipment. They don't pay the entire cost of the program. Some of that's covered by the Metropolitan Council, but the sponsors do pay a fee to enroll Lake. They're responsible for recruiting the volunteers. They have more direct involvement in their communities and better connections and knowing people, so to speak, than we at the Met Council do. So they're in charge for recruiting volunteers, and also they're responsible for ensuring participation. So if you have a volunteer who's not going out as much as they should, then it's up to the sponsor to kind of give them a little nudge. And then also they need to pick up the samples from the volunteers, and then Metropolitan Council then goes and picks up the samples from the sponsors. But our charge is to manage the program overall, and we prepare a final report, and I'll get into that later. Train the volunteers, that's our responsibility, provide quality control, and then we provide the sampling equipment, which the sponsors purchase from us. But so that's kind of how it all works, and it's been been working good so far. So I mentioned the monitoring programs and focus a lot on eutrophication, the trophic status, and if trophic status is changing over time. And that, a lot of this might be kind of, you guys all know, we probably know a lot about this already, being at the PCA, but, I just wanted to, describe, the eutrophication as a process of nutrient enrichment. And then with culture eutrophication, that's just acceleration of that process, mainly due to, the way the land has changed in use over time since European settlement and expansion of urban and suburban areas and conversion over to agriculture, all that kind of stuff. So that picture there is from Fish Lake down in Scott County. It was taken at the boat landing there by Jamie Rockney at the Prior Lake Watershed District, and it shows kind of a nice eutrophic mess of some filamentous algae and maybe some other types of algae in there, possibly a cyanobacteria bloom that's washed ashore. And you can see the stuff, paint-like stuff on the ramp of the boat landing. So that's what we're talking about. And then here's a picture. I think many of you may have seen this picture. This is called Algae Boy, and I believe this is from a beach on Lake Byllesby. And so this is quite striking. But it just shows how the effects of eutrophication increases aquatic vegetation growth and abundance, and algal blooms, including cyanobacteria blooms. But there's other effects of eutrophication, and I won't read through all these, but obviously is something that affects the water clarity and increased vegetation as well, affects recreation, but there's other things that it affects, such as killing fish and loss of habitat and biodiversity for certain fish populations and other animals and plants, causing odor problems, and also the problem of harmful algal blooms is a health issue to animals and humans. You know, the concern of documented cases of dogs dying, drinking water from tabs in a lake, or even horses dying. So, and humans getting sick. So eutrophication goes more than just recreation. It affects people's health and well-being of other animals. So then the monitoring of trophic status, again, might be an old hat to some of you, but we look at total phosphorus, chlorophyll, and Secchi transparency. And so the phosphorus is the main driver of culture eutrophication, and chlorophyll is an indicator of the primary production of the lake. And the Secchi transparency depth gives an idea of the water clarity, how much light is penetrating into the lake. And one thing I want to point out, though, is when we monitor, we are typically going out to the middle part of the lake, either over the deepest part of the lake or a central portion. And so we're focusing on the open water quality or the open water trophic status. So we're not looking at near shore. We could do that, but that would be more of an intensive study. So when we go out and monitor just to do status, it's typically out in the middle part of the lake. And so we don't see a lot of, depending on the lake, if it's not a shallow lake, there's not a lot of vegetation growing out there. So that's why we focus on chlorophyll for algae. But it's not to say that shallow lakes, when they have more abundant aquatic plant growth, most of that primary production is focused into plants rather than algae. So that has an effect on how we determine trophic status for those types of lakes. But generally, the thing is as phosphorus goes up, it increases algal production, which increases the chlorophyll content that we measure as a proxy for algal population. And then as that increases, the water clarity decreases. A lot of that's might be old hat to a lot of you, but I just want to bring that up because that's kind of what our program focuses on. Now I mentioned Chub Lake before, and I'm showing you some data here from 2011 that shows just over time how phosphorus and nitrogen trend for this lake over a monitoring season. So over here we have the spring, and then a little spike here, but then it drops back down. Then we have this gradual increase over the summer. And the total phosphorus, this is pretty high for this, for a lake. It's around up 160, 180 micrograms per liter. And then down here, then in this graph, we show chlorophyll and Secchi. The blue line is the Secchi depth, and start off relatively clear with over a meter depth of water clarity, but then over time, over the summer, it gets pretty green and pretty turbid, and we get water clear is about 0.3 meters, which is not very good. And then that then tracks with the amount of chlorophyll that's being produced, making this is pretty high, 160, 180 micrograms per liter as well for chlorophyll. And then this chart down here shows the dissolved oxygen near the surface, about a foot below the surface. This shows trends of temperature and oxygen over time. And with all that algae in the water, we typically go out during the day, so it's actually pretty high oxygen content in the surface waters. All that algae, a lot of photosynthesizing, making lots of oxygen. But it's a different story near the bottom. It's not so high down there. But that just gives you a kind of an idea of what we do, or what we kind of the data we collect, and just want to show you that. And then quickly here, you know, this is a change. This is a SECI disc. This is actually a volunteer type SECI disc, which is all white. We get these from the PCA. But here, this is in May when the water clarity was, you know, around, let's see, a little over a meter to, let's see, it's May 3rd. So this is still over a meter water clarity, but this disc is being showed at 20 centimeters just to show you a comparison to another date in August where the disc is at 20 centimeters down. You can tell it's a lot more green and a lot less clear. So it's one of the things we do when we go out there. And then so also for staff monitoring, I want to show you some results that we had for Lake Byllesby. This is Lake Byllesby here. The dam is located on this end of the lake. It's quite a bit deeper on this end, and then the lake extends all the way out over here to, this is where the Cannon River enters, and there's actually an estuary over here with quite a lot of sediment that's filling in, that's dropping out of the river once it enters the slow waters of the reservoir. And I'm going to be showing you data from site 3, which is in the mid reservoir. We had 2 other sites. We had a site down here by the dam, and then also one, let's see, it's over in this area here. That's another site that kind of gives us an idea of what's coming into the reservoir. And it shows a channel here, and then actually the river. This is the old river channel. So it's a good place to sample to get an idea of what's coming in. So I'm going to show you some information, some data on site 3 here. These are the, let's see, what's this? This is total phosphorus over time. This is surface sampling. Site 3 is only at 4.5 meters deep. So we only collected a surface sample. So these box plots are showing a season's worth of data for each year. So this is 2013, 14. And then 15 and 16, we didn't go out. The reservoir was lowered to make some repairs and improvements on the dam. So it was, we didn't monitor those years. But I just want to show, it doesn't really show any, at least by the box plots, no significant change in phosphorus since 2013. And it shows this is last year's data, 2019. And so there's some variability, but it doesn't seem like there's an overall trend. If we look at the water clarity, this is SECI depth. Again, and it's hard to say if there's a change. The box plots are kind of overlapping. So doesn't seem to be a change in water clarity. But if we look at nitrogen, if we look at total Keldo nitrogen, which is a measure of, what that measures is organic bound nitrogen and also ammonia. This has given us kind of an idea of the type of nitrogen that comes from biological sources, such as manure and human waste, and you know, basically from biological sources as opposed to like nitrate from fertilizer. So, so this trend, we're actually, I think we're seeing a trend here. Starting in 2013, we're up around 1.5 milligrams per liter, and then we dropped down to 1. And it just it seems like there's a trend there based on the box plots. We haven't done a statistical analysis on this, but this is kind of interesting. Where we're seeing this decrease in nitrogen, and I'm wondering how this might affect the algal composition in the lake. In past, just to let you know, what I've observed out there is that the Lake Byllesby's got a lot of or a persistent Aphanizomenon bloom. It's a type of blue-green algae, and it's very. It seems like it's always there. But it'd be interesting to see if that population is different. And we haven't been taking algal samples to do a population assessment, but that would be an interesting question to answer. Okay, so let me, that was some data. That just kind of shows you what we collect and what the information we can provide. from our programs. And then I want to get into the Lake Water Quality Report Card. This is the lake grading system. And it was developed by Dick Osgood back in the late 80s. And basically what the purpose of it is to report, complex and related information in a simplified manner to an audience that, doesn't understand the intricacies of lake science and water quality science. So it's based on an A through F system. So it looks at Carlson's Trophic State Index, or TSI. And that's a biological production based index, since it focuses on the chlorophyll. But see, the issue is that we go tell the public, well, it's got a TSI of 30. Most people don't understand what that means. So if we can show them, a grade instead, they say, oh, I get that. I can relate to what an A means good and F means bad type of thing. And C is kind of an average. And so the Lake Quality Report Card, then it focuses on open water quality, as I mentioned before, typically over the deepest spot of the lake. So we're not looking at near surface areas. And it's limited to comparison of lakes in the Twin Cities area. So you really can't apply this report card to, let's say, the lakes up in Brainerd or up in the BWCA. So it's pretty much focused on the Twin Cities area. And what we do is, how it's developed is we have a ranking of summertime means. And so the population of lakes that we had information on from the period of 1980 to 1988 was ranked percentile wise. So the A lakes, or let me step back, the percentile, the top 10 percentile, or I should say the bottom percentile for TP and CLA. So the lowest 10 percentile for TP, that would be the mark, or the distinction of the 10 percentile for TP is 23 milligrams per liter, and chlorophyll A is 10. So the lake has 10 micrograms per liter of chlorophyll or less, it's in the 10 percentile. Secchi depth, if it's 3 meters or greater, then it's in the 10 percentile. And so these different percentiles then were generated from the database of the lakes from 1988. We had these different percentiles with these different values. And then we ranked the percentiles according to a grade. And so percentiles of 10 or less would be an A, percentiles of 10 to 30 would be a B. And then you have your percentiles for C, D, and F. So anything greater than 90 percentile would be an F grade. And so those summertime means then are then summarized here to give you an idea of what constitutes a grade. So if you got a TP of 40 milligram, that's not right. This should be about, oops, backed up. Got an error in my table. The units here for TP should be micrograms per liter. So that's not, that was true. That'd be like crazy high. So micrograms per liter. So if you had 40 micrograms per liter, it would fall in this range. So that would give a phosphorus grade of C. And similarly, you rank, you grade the other parameters with according to those percentiles and what your mean is. And we base the mean, what we define as summertime is from May through September. Opening of fishing season starts early May, so Memorial Day is in May, and people start getting on the lakes in May. So that's why we include May. And then you need at least 5 results during the summertime period to determine a grade. So we have to have a minimum amount of data. And so then what we do is we take the lake water quality, or the lake water quality grade, which is the overall grade. What we do is we take the 3 parameter grades. So we get a TP grade, a chlorophyll grade, and a Secchi grade. And then we kind of do a grade point average. And that grade point average then determines then what the water quality grade is. So that's where our lake grades come from. It's basically kind of averaging the 3 parameter grades. So an A grade we consider exceptional. That's pretty good for the Twin Cities metro area. B is very good, and C C is average, D is poor, and F is very poor. And then we have different descriptions of each of what those mean. And so then with all this information, we report this out every year. We have a lake water quality summary report, which we put out. It's 4 pages, and sometimes it's 3. Those 3 to 4 pages is very small. And this shows the 2018 lake water quality summary report. This is the latest one we have. We're currently working on our 2019. And so that just shows the cover page. Then we also put out an annual lake report, which is over 600 pages. And the reason why this is so big is that we do a report on each individual lake that's enrolled in our camp program and our staff program. And each lake report is 3 pages. So we have, close to 200 lakes, 3 times 2 is 600. So that's why it gets so big. We put that out every year as well. We also have our data available on our environmental information management system. This is available via the web through our EIMS link on the Metropolitan Council's webpage. And we also send the data to the PCA, which we put into ECIS. And then here's the last page of our water quality summary report. This basically shows the map, of the 7-county metro area and the lakes that we monitored. And then we also indicate a color code for the lake grade that it received. And so this is from 2018. And so we have a variety of lakes from A to F. And we do a little summary down here, just giving a histogram of the distribution of lakes. We actually have more A lakes and B lakes within the monitoring program, or the lakes that we have enrolled. But I just want to point out, we get pretty good coverage of this part of Hennepin County, and then Carver County is fairly spread out, and then pretty good monitoring over throughout. Except we are missing quite a few lakes in Ramsey County, and this parts of Hennepin, and the Lake Minnetonka watershed, and also up in Anoka County. And the reason for that is because those local units of government, particularly the Anoka Conservation District, Ramsey County, the Three Rivers Park District, and Minnetonka Creek Watershed District, have pretty robust monitoring programs. And so they're doing a lot of the monitoring in that area. So we don't want to duplicate efforts with that. So a lot of it is being taken care of by others. We have a lot of lakes in Washington County because we have a relationship with them through the Pro Camp. That's why they're included. And Carver County too. Carver County used to be part of the camp program. 2018 was the last part. They decided to go on their own. They're pretty far away from our lab, which is located over here in downtown, or just downriver of downtown St. Paul. And then Dakota County in this area is pretty sparse because there just aren't very many lakes, very few lakes down in that part of Dakota County. So anyways, that's kind of what we show every year. People can get an idea, look on here and see what their lake got for lake grade. Oh, I just wanted to show you real quick about, well, I'm getting close to running out of time. So this is what our lake report looks like. This is for Chubb Lake. This is 1 page. It's gives a summary of the statistics and the grades. And then we show the data on the next page, showing a lake map where the monitoring site is, a summary of the data and charts. And then we also show historical lake grades that the lake has received over time. One thing I like about this one is that 1980, Chubb Lake got a D. And then if you look at the lake grades over time, they tend to be getting worse. And by 2018, it's now a solid F. So this is a crude kind of way of doing a trend analysis, but it looks like Chubb Lake has gotten worse since, well, for the past almost 40 years. Just wanted to go briefly some of the current projects that we're working on. We're updating our lake grading system. We want to revise the grading curve with recent data. It hasn't been changed since the late 80s. It was checked in around 2000, and it showed not very much change since compared to the previous curve, so that curve was kept. But we're looking at the grading curve with recent data to see if there's any changes. And so has, so to speak, has the class improved? Has their grading curve stayed the same? Has it improved? Has it worsened? So maybe kind of a different way of approaching a kind of a trend analysis. But we're also going to address some common critiques of the system. One is particularly is the shallow lakes. We want to create a separate grading curve for that because one of the issues with shallow lakes is that secchi depth measurements are sometimes impossible to come by. If you get a clear water lake, the secchi depth becomes visible at the lake bottom. And well, then that's not you don't know what the water clarity is because the lake, you can still see the disc on the bottom. Or if there's a substantial vegetation growth, that's common in shallow lakes, then the secchi disc gets blocked by vegetation and macrophytes, and so you can't get a true water clarity measurement. So we're trying to figure out how we can tease out shallow lakes out of the grading curve and make a separate grading curve. Another thing, we want to incorporate other subjects beyond trophic status indicators. That's one of the critiques of the system, and that is, for example, if a lake's infested with zebra mussels, zebra mussels filter out the water and tend to make it clearer, so it makes it look like the lake is improving. Might go from a C to an A, but the problem is then you got zebra mussels, and that's not considered good. So we're looking at AIS infestation as a way to incorporate it, grading the lake. Also impairments for impairment listings, beyond eutrophic listing. Fish consumption advisories, maybe some other ideas that we can come up with. So that's one of the things we want to do with our priority lake list. And then create a priority waters list. Right now we have a priority lakes list, but we're also working on creating a prioritization list for streams and rivers. This is part of an update for the next generation water resource policy plan. And we're utilizing an ecosystem services concept to generate ideas for water body uses. And the ecosystem services system we're using is common international classification of ecosystem services, which is a European led effort. And we're going to prioritize the water bodies based on these uses that come out of the ecosystem services. Then we're also looking in the future to do a regional water quality trend analysis and have the region's lakes water quality change over time, and are there certain regions of the metro area that are experiencing different changes? And if it's changed, can we discern the cause of that change? And this is kind of a big ask, I think, but we'll look at it and see what we can do. So those are kind of the projects we're working on to keep the lake monitoring program going and relevant. So I'm done, and I'll be happy to answer any questions.
All right, thank you, Brian. We did have a question or an inquiry earlier about discussing wild rice a little bit more. Just wanting to learn a little bit more about what you found in that wild rice study.
Well, the wild rice study was interesting. It was based on the DNR study. It was based on actual measurements of stands, but they also talked to Indian tribes in the region to get an idea of oral histories behind where wild rice was located. But generally, the trend is wild rice is disappearing, and that's kind of what I got out of it. But there are some lakes that still had some documented stands of wild rice when the DNR survey was done in the metro area. So, that's one of the important reasons why we take a look at sulfate, because of its impact on as a measure of sulfur pollution for wild rice. Wild rice is sensitive to sulfur pollution. So that's kind of what we, I guess, I found out about it, and the importance that wild rice has to wildlife, and how it's an indicator of water quality overall too. Is that
yeah, that's great, thank you. We have another question in the chat, is that for lakes being monitored by other agencies in the metro, could you utilize their data to apply to your grading system?
Yeah, that's our plan, actually, is to use their data because, you know, as I said, we don't, a lot of the priority lakes that we don't monitor because they're monitoring it, or others are monitoring it. So we're hoping to use their data. And so we'll have to look into, you know, how do we compare results, and, you know, we'll have to look at detection limits and all that kind of stuff too. But that's our hope, is to incorporate their data. And we, you know, we can get that data off the PCA's ACCESS, or, you know, Environmental Data Access System. That's one source. And then the other is, if we can't find it there, then we'll just reach out and ask them if they'll be willing to share that. So.
Well, that's great. It'll be nice to see a completed map of the metro with all that grading system that you guys have.
Yeah. Yeah. That's one of our, we want to be able to grade lakes beyond what we just monitor, I guess. And that would be focused on the priority lakes.
And then I'm not seeing any other questions in the chat. If anybody does have a question, you certainly could unmute and ask Brian yourself if you were interested. Otherwise, he's got his email address up there, and I'm sure if, oh, we've got one more here. Does Met Council implement corrective actions to correct water quality?
No, we don't do that directly. However, we are involved in the local comprehensive plan process, and during that comprehensive plan process, we review like a water resources policy plan and look into what issues have they identified that need to be corrected. And this, you know, it could be through TMDLs or through RAPs, things of that nature. And we'll look into see, okay, are they taking things into account, or do they have things in their capital improvement plan? Have they followed through on past actions? And we'll do a review and comment on those plans with respect to implementing BMPs to help improve water quality and flooding and things of that nature as well.
We have another question here is, how will the nuances of AIS factor into the updated grading scale? Curious about zebra mussels versus other AIS that have more negative effects.
Yeah, that's a big question that we're trying to come up with an answer to, how we're going to incorporate this, because, you know, different invasive species have different effects. And you know, zebra mussel example I gave, you know, it can improve water clarity. There's issues of Eurasian water milfoil infesting a lake, and basically out-competing the algae, and you end up getting clear water that way. So how do you incorporate that into it? And then other issues, you know, I'm thinking, what happens when we get spiny water flea here? How's that going to affect things with predation on zooplankton and stuff? So that's really that's part of the project, and updating the lake grading system, how we're going to incorporate that in there. And I think it's going to be tricky, but that's what we're going to try to hope to solve.
All right, we've got another one last question here is there any issues with mystery snails in the metro? A lake up north has them, and they have mass die-offs following the beach late July or so.
I'm not sure specific about mystery snails and major issues with them. I am familiar with, you know, lakes north and even northwest Wisconsin that have them, and it's just anecdotally, it seems like they're out competing and replacing native mussels. That's just anecdote from my own observation. I don't. So I am, as far as the metro area goes, I guess that would be based on an AIS designation. And from my experience, most AIS designations have been related around zebra mussels and invasive plants and fish. So I haven't seen, or off the top of my head, any kind of big issue with mystery snails here in the metro. But that'd be worth looking into.
All right. Well, thank you again so much, Brian, for joining us and sharing a little bit of your work with all of us. We really appreciate you taking the time and being with us today.
Well, thank you for having me. I really enjoyed it. Thank you.
Yeah, well, and we'll see everybody in 2 weeks, where we will actually have another Met Council presenter from the Metro wastewater treatment plant to talk about some of the research going on there. So please join us in 2 weeks and let others know if you think they might benefit from hearing about the research at the Metro wastewater treatment plant. So that is it for now. We're going to sign off here and hope that you guys all have a really great rest of your day.
Thank you, guys.
Thank you.